Are we alone in the universe? It's a question that's haunted humanity for centuries, and the definitive answer has remained frustratingly elusive. But as technology has advanced and our reach into the cosmos stretches even further, a final ruling may be closer than it's ever been. From the infamous wow signal to alleged alien fossils and even signs that life may exist on Mars, the evidence is stacking up, and the needle is inching ever closer to final confirmation. On the other hand, as convincing as the existing body of evidence is, the scientific community is now shifting to an increasingly more relevant question. What would actually be accepted as ultimate proof positive? The reality is that the dilemma of life beyond Earth is more complicated than most people imagine, and it's not impossible that we fail to recognize extraterrestrial life if we do find it, or we may have already found it and then failed to acknowledge it. At this point, it's becoming a matter of how you interpret the evidence. Otherwise, the situation may remain deadlocked until such a time as aliens provide some sort of formal introduction. 1977, the wow signal. Starting off with one of the most widely known bodies of evidence, the wow signal is regarded by some as the most compelling sign of intelligent extraterrestrial life ever. Recorded by the Big Ear Radio Telescope at Ohio State University on August 15, 1977, 72 seconds of a signal was detected and recorded. So abnormal was the occurrence that astronomer Jerry R. Emmon, working on behalf of SETI, wrote "wow" in the margin. The signal originated from the constellation of Sagittarius, was crystal clear, and it occupied a narrow band, all indications that it was intentional. To put that in a nutshell, if we were to detect a broadcast from a non-human intelligence, this is almost certainly what it would look like. If that's the case, however, why hasn't the wow signal been hailed as the most groundbreaking observation ever made? Well, as compelling as it seems on the surface, there are more than a few complications that prevent the printout from being definitive. First and foremost, there is little debate as to whether the signal existed and whether it was accurately recorded. The Ohio State University Radio Observatory, otherwise known as Big Ear, was used extensively between 1965 and 1971 as part of the Ohio Sky Survey project. The initiative was to survey and identify galactic signals, with our galaxy being an ocean of naturally occurring radio noise. Everything from planets to pulsars produced detectable signals, and Big Ear was used to observe and study these signals in an academic capacity. There is, therefore, no question as to whether Big Ear worked and whether it produced reliable results. Following the Ohio Sky Survey, the Big Ear was reassigned to the Search for Extraterrestrial Intelligence, or SETI. That organization is well known today, but at the time it was still seen as a fringe scientific effort. Not too surprisingly, after years of using Big Ear, SETI didn't pick up anything particularly interesting, keeping in mind that the job at the time involved manually poring over mountains of printouts produced by an aging IBM 1130 computer. Then, on the night in question, Jerry R. Emmon hit on something that made his heart stop. As he scanned the printouts for the day, a signal jumped out at him, appearing as 6EQ-UJ5. Now, to be clear, the sequence of numbers and letters weren't some sort of hidden message, but rather an indication of the intensity of the signal versus background noise. The Q and the U in this case mean that at its peak, the signal was 30 times more intense than background noise. More compelling still is that the signal appeared on the 1420-4556 MHz frequency, a band reserved for astronomical research. Neither academic, private, nor commercial organizations are allowed to broadcast in that range, meaning that the wow signal almost certainly wasn't produced locally. More to the point, 1420 MHz ties in with a paper written in 1959 by physicists Philip Morrison and Giuseppe Cocconi. The frequency is naturally emitted by hydrogen, and the pair speculated that if alien life was intelligent and had the capacity to broadcast, they would choose this frequency given hydrogen's inherent importance for organic life. The wow signal, therefore, correlates perfectly on all counts, taking the probability of non-human intelligence to a whole new level. Now, yes, all very exciting, but let's slow down and get some perspective, shall we? There is no question that the signal is compelling, and initial interest was indeed a frenzy, but as time went by, the chances of the wow signal being related to aliens gradually declined. Every effort was made to detect the same signal in the same location, but each subsequent attempt came up negative. If the signal was alien in nature and was an effort to make contact, the broadcast would certainly have been repeated. Explanations soon shifted to a rare astrophysical anomaly, and make no mistake, there are countless cosmic anomalies capable of producing a similar signal. Emmon himself in 1994 is quoted as saying, "We should have seen it again when we looked for it 50 times. Something suggests it was an Earth-sourced signal that simply got reflected off a piece of space debris." He later contradicted this statement in 1997, saying, "I'm convinced that the WOW signal certainly has the potential of being the first signal from extraterrestrial intelligence." His lack of a definite stance is indication enough that the signal is controversial, but the official jury is still out as to what exactly it was and what produced it. There are many possible explanations, including everything from energized hydrogen clouds to a random passing comet. At this point, the region of the cosmos has been scanned countless times, and National Geographic even sent 10,000 Twitter messages to the location in a 35th anniversary celebration of the event. Needless to say that if we plan on communicating intelligently with aliens, Twitter might not be the best option. 1996. Martian Fossils. As far as ultimate confirmation of extraterrestrial life is concerned, 1996 was one of the most chaotic years in history. NASA scientist David S. McKay made a shock announcement that he and his team had discovered alien fossils in a meteorite, and international media erupted. The meteorite, referred to as Allen Hills 84001 after the area it was recovered from in the Antarctic, was originally found on December 27, 1984 by an ANSMET team. ANSMET is part of the Polar Program funded by the National Science Foundation, responsible for sending explorers on meteorite hunts in the Transalpine Mountains. The 1.3 kilogram ALH 84001 meteorite was recovered, stored, and re-emerged in 1996 for investigation. An analysis revealed that the meteorite had almost certainly come from Mars, had been knocked off the surface by an ancient collision, and had drifted through the solar system for several million years before touching down in the Antarctic. More importantly, a deeper analysis found what appeared to be evidence of microbial alien fossils. So groundbreaking was the announcement that US President Bill Clinton gave a nationwide speech marking the day as a truly momentous occasion. Mr. Clinton probably shouldn't have jumped the gun. Now, ALH 84001 is an interesting meteorite regardless, given its age and the distance it traveled before impacting Earth. Deeper exploration says that it may have formed billions of years ago, was knocked into space some 17 million years ago, and landed on Earth around 13,000 years ago. There are also clear signs that the rock came into contact with liquid water on the Martian surface, and this in itself is important, confirming that abundant water was indeed once present on Mars. Vicki Hamilton of the University of Hawaii even narrowed down the exact region that the meteorite may have originated from, pinpointing Eos Chasma in the Valles Marineris Canyon. As far as the alleged fossils are concerned, however, the facts are a lot more up for debate. While investigating via electron microscope, McKay and his team discovered 20 to 100 nanometer structures, and at a glance, there is reason to believe that the shapes may be fossilized bacteria-like lifeforms. Granted, the lifeforms would have been smaller than even the smallest known cellular lifeforms on Earth, but in this case, McKay insisted that he was identifying previously undiscovered alien nanobacteria. To be fair, McKay did find something interesting. He just made a hasty judgment in announcing the discovery as fossilized alien life. Controversy surrounding his announcement was immediate, and skeptics the world over stepped up to point out that the nanostructures could simply be contaminants, perhaps carbon left over after liquid water evaporated millions of years ago. McKay argued back that such contaminants had appeared on other meteorites and didn't resemble those discovered by his team. The key difference, according to McKay, was that similar contaminants appear on rock surfaces, while his are embedded in the rock itself. Now, the conflict between McKay and the broader scientific community went on until McKay's passing in 2013, and the bottom line is that there is still no definitive answer. The nanostructures could be billion-year-old fossilized bacteria, or simply a representation of wet Martian conditions that existed eons ago. Countless papers have been written on the subject, and most tend to argue against the living bacteria hypothesis. Most noteworthy of all is an experiment run by a team at NASA. In an effort to put the matter to bed, the team successfully recreated similar nanostructures using nothing but distinctly terrestrial rocks and water. An additional paper published in January 2022, meanwhile, once again reaffirmed that the structures were simply carbonation formed by basalt rock interacting with 4 billion-year-old hydrothermal fluids. Whatever the truth, the incident was a major wake-up call for the scientific community the world over. The incident emphasized just how thin the lines are when attempting to identify unknown life beyond Earth. 2001. The Evolved Drake Equation. The Drake equation is a fairly well-known formula, standing as a probabilistic argument for how many intelligent alien civilizations may be detectable in the Milky Way. According to the equation, we should have hundreds of thousands, if not millions, of galactic neighbors, some likely within detectable range. Though, as compelling as the numbers are, the Drake equation is a lot more complicated than is generally represented, requiring a great deal of additional context. American astrophysicist and astrobiologist Frank Drake is most often associated with the equation, but the concept was around long before he put pen to paper. Original inspiration came from the already mentioned Philip Morrison and Giuseppe Cocconi, otherwise known as the 1959 pair that proposed the hydrogen frequency as an alien hotline. It was their paper that prompted Harvard astronomy professor Harlow Shapley to suggest, quote, "The universe has 10 million suns." That's a 10 followed by 18 zeros, similar to our own. 1 in a million has planets around it. Only 1 in a million has the right combination of chemicals, temperature, water, days, and nights to support planetary life as we know it. This calculation arrives at the estimated figure of 100 million worlds where life has been forged by evolution. A few months after Shapley's musings, Frank Drake started work on Project Ozma, the first scientifically based attempt to search for extraterrestrial intelligence. Drake made use of the 26-meter dish located at the National Radio Astronomy Observatory in West Virginia and got to work systematically monitoring two nearby suns, Epsilon Eridani and Tau Ceti. His early work turned up nothing, of course, but determined to motivate other capable scientists, he decided to host the first SETI meeting in 1961. He therefore worked on his equation as a way to stimulate constructive conversation at the meeting, saying, "As I planned the meeting, I realized a few days ahead of time that we needed an agenda. And so I wrote down all the things you needed to know to predict how hard it's going to be to detect extraterrestrial life. And looking at them, it became pretty evident that if you multiplied all these together, you got a number, n, which is the number of detectable civilizations in our galaxy." This was aimed at the radio search, and not to search for primordial or primitive life forms. Simply put, he wanted to inspire his peers into real thought as to how likely nearby alien civilizations are, and so put together a rough formula as a conversation starter. Regardless of his intentions, the media took his presentation at face value, ran with it, and presented his equation as a definitive calculation. The equation never was meant to be definitive, so some today may have a skewed idea of just how likely alien neighbors really are. Looking at the equation itself, we won't go into too much detail, but it boils down to a few easily understood concepts. Drake used parameters, including the average formation of galaxies, the number of those stars that have planets, the average number of planets that can support life, and put the data up against the amount of time it takes for intelligent life to develop, the number of those civilizations that have the ability to broadcast information, and how long those signals will be detectable on Earth. With this basic framework, the equation estimates n, the result, as being between 100 and 1,000 million detectable radio signals. With that being said, the three aspects of his equation most commonly argued are the last three: the number of viable planets, the number of tech-savvy civilizations, and how long the signals may be detectable. The dataset used, simply put, is so drastically variable on so many levels that the Drake equation is nothing more than wild guessing. As controversial as it was, the Drake equation still captured the public's imagination, stuck around for decades, prompting multiple iterations as more accurate information became available. A refined version was put forward in 2001 with updates in regards to planets existing in the Goldilocks zone and the probability of liquid water existing on those planets. Using the new method, the Drake equation now suggests there are roughly 100,000 intelligent civilizations in the Milky Way, and just one may be within detectable range. Meanwhile, as far as SETI is concerned, the organization has conclusively ruled out any widespread alien communication on the proposed hydrogen frequency. This doesn't mean that extraterrestrials aren't in our vicinity. It just means that they're not constantly chattering on the proposed frequency. 2004. Methane in the Martian atmosphere. Mars has been a point of focus for decades, with NASA, Roscosmos, the European Space Agency, and the Chinese National Space Administration investing billions in understanding every facet of the red planet. It's been confirmed that Mars once had an abundance of liquid water, perhaps even oceans, and that ice still forms at the poles. What hasn't been definitively proven, as touched on with the ALH 84001 meteorite, is whether microbial life ever flourished in the chaotic climate. The debate went back and forth for decades until, in 2004, a potentially definitive answer was thrust into the spotlight. To the surprise of everyone, an orbital observation suggested the bacterial life may be teeming somewhere below the Martian surface, brought on by the unexpected discovery of Mars-based methane. An investigation got underway and a bizarre mystery was uncovered, one that only seems to get increasingly more bizarre. The first signs of peculiarity came from the European Space Agency's Mars Express orbiter, an investigative probe primarily aimed to search for signs of water. The probe launched on June 2, 2004. Augustin Chiccaro was the lead on the mission, and using the orbiter's specialized planetary Fourier spectrometer, he unexpectedly found signs of methane. Now, this might not seem like a big deal, but put into the right context, it is an absolutely extraordinary find. On Earth, methane is almost always inseparable from the presence of life, coming either from natural decomposition or produced by bacteria and other living organisms. At the risk of being crude, methane is a byproduct of the digestion process, generally released as flatulence. Bacteria likewise produce methane via decomposition, which incidentally is why landfills smell terrible. It's the bacteria that creates the odor, not the garbage itself. The Mars Express orbiter presented the evidence of the methane to Chiccaro, after which the discovery was confirmed by a number of independent sources using ground telescopes, including Michael Mummer and his team at NASA's Goddard Space Flight Center. Mummer provided a breakdown of the methane, confirming that the gas existed in hotspots on the Martian surface. The data was all coming together, and signs were firmly pointing in the direction of living organisms. Though there was one other explanation. The gas may also be produced by subsurface volcanic activity. Following initial excitement, the methane trail went cold, only re-emerging in 2014. Curiosity rover, while exploring Gale Crater, again detected signs of methane, with one instance showing a spike that peaked at 7 parts per billion. The gas presence lingered for months before fading away until years later when it began to appear in readings. This time, however, it became clear that whatever was producing the methane, it was somehow tied to the Martian seasons. The parts per billion peaked during the Martian Northern Hemisphere summer at 0.7 parts per billion, then faded away slowly, only to return the following summer. A seasonal cycle again leans towards the methane being biological in nature, but more evidence was required, and so the ESA attempted to settle the matter once and for all. The Trace Gas Orbiter, specifically designed to detect even the minutest presence of gas, was launched, arriving at Mars in 2016. Only, against all expectations, the new orbiter served only to take an already mysterious situation to a whole new level. The Trace Gas Orbiter found no signs of methane whatsoever, and all involved were left completely baffled. Planetary scientist at the Royal Belgian Institute for Space Astronomy, Anne Corrine van Daly, addressed the matter at an American Geophysical Union meeting. She stressed that the orbiter was sensitive enough to detect just 50 parts per trillion, yet had come up completely empty. As discouraging as the result was, it did offer some insight into the anomaly, though. If the Trace Gas Orbiter found no atmospheric methane, then the source must indeed be linked to the Martian surface. Chris Webster, a planetary scientist at the Jet Propulsion Laboratory in Pasadena, confirmed as much, saying that the source must be seepage through the planet's surface itself, either by subsurface volcanic activity or living organisms residing somewhere below ground. The TGO orbiter continues to operate to this day, and in its 9 years of service has found barely any evidence of methane. It did, however, detect significant amounts of water vapor, which is an important discovery in itself. As to where the methane comes from, that's still a mystery, and a good chance remains that it's being produced by still undiscovered microbial life. 2025. Biosignatures on K218b. Perhaps the most compelling evidence of extraterrestrial life is surprisingly recent. It's from April this year, in fact, coming via observations from NASA's James Webb Telescope. An astrophysicist team, led by Niku Madhusudan at the University of Cambridge, trained his telescope on a planet designated K218b, 124 light-years from Earth. What they found is that the planet's atmosphere is rich with dimethyl sulfide, DMS, and like methane, DMS is a strong indicator of life. On Earth, DMS is associated with living organisms, specifically aquatic phytoplankton and bacteria. It just happens that K218b was previously speculated to be a Hycean world, meaning that it had an abundance of hydrogen in its atmosphere and is likely covered in vast oceans. Madhusudan said, "This is the strongest evidence to date for a biological activity beyond the solar system. We are very cautious. We have to question ourselves both on whether the signal is real and what it means. Decades from now, we may look back at this point in time and recognize it as when the living universe came within reach." This could be the tipping point, where suddenly the fundamental question of whether we're alone in the universe is one we're capable of answering. The evidence presented by Madhusudan and his team is compelling, to say the least, and as far as remote observation is concerned, this is about as good as it gets. Yet, as with all other evidence on this list, the discovery has raised a storm of ongoing controversy. Addressing the discovery with the New York Times, planetary scientist Christopher Glean from the Southwest Research Institute in Texas gives his opinion, explaining that although the observations regarding K218b are interesting, he remains skeptical. He elaborates, "We need to resist the temptation to find a smoking gun. The search for life is hard. For a convincing case to be made, multiple self-consistent lines of evidence will need to be assembled. Reproducibility is a hallmark of science. We need to see that moving forward. Did they find a needle in the haystack, or just a sharp piece of hay? Others have gone so far as to accuse Madhusudan and his team of manipulating data, pointing out that DMS may not even be present in the planet's atmosphere at all. Keep in mind that telescopes, of course, can't detect molecules directly, but instead observe the light spectrum that filters through an atmosphere as it passes by a star. It is possible to make fairly accurate deductions based on the observable light spectrum, but there is also room to massage the results in favor of one observation over another. It's also possible, for example, that K2-18b may be a gas planet or may have oceans of magma rather than water. Glean and others have also since conducted their own analysis of K2-18b and have concluded that the planet may be too close to its sun to support any liquid water at all. Matt Geng, a planetary scientist at Imperial College London, echoed the sentiment, saying, "When a discovery is as monumental as the discovery of alien life, the bar is set very high for convincing evidence. As a geologist who studies planets, I question the assumption that these molecules can only be produced by life." He added that if the presence of DMS is confined in the planet's atmosphere, quoting again, "then it's possible we might be seeing evidence of some cool chemistry rather than biochemistry. As Carl Sagan used to say, life is the hypothesis of last resort." So it seems that even our most recent evidence of extraterrestrial life is debatable, and at this point, you start to wonder if any evidence could be conclusive short of aliens personally introducing themselves. More to the point, would we even know extraterrestrial life if we did find it, or would we be so tied up in what constitutes as evidence that we miss the signs entirely? Life as we don't know it. NASA and other space exploration agencies have been focusing on life beyond Earth for decades, but have only succeeded in making something very evident. Few can agree on what actually constitutes definitive evidence. Be it methane, DMS, or radio signals, on Earth, virtually everyone would agree that these are undeniable signs of life. Yet, the question now being raised time and time again is whether these Earth-centric rules should apply to life on other planets, and whether established biosignatures really serve a purpose when we're dealing with complete unknowns. Life on Earth is carbon-based, cellular, and relies on self-replication, so assumptions are that life on other planets could be identified by these same characteristics. But there really is no reason to believe that alien life would follow the same framework, especially if involved in a Haitian planet, as K2-18b is speculated to be. Make no mistake, the evidence we've covered today is compelling. But to iterate on Professor Glean's words, it's very difficult to find a needle in a haystack when we don't know what the needle looks like and may be looking in the wrong haystack. Philosopher of science Carol Cleland addressed the exact same dilemma, coining a phrase that's becoming increasingly more relevant. We're trying to find life as we don't know it. The longer space exploration organizations look, the more apparent it becomes that it's highly unlikely there will be consensus on anything short of a miraculous discovery, meaning that we probably shouldn't be holding our breaths. This, of course, is a much broader conversation, and as it stands, there are a few nearby hotspots apart from Mars that are currently earmarked for further investigation. The moons of Jupiter, Ganymede and Europa are both top of the list in terms of potentially supporting life. Both are confirmed to have liquid water, though imprisoned below icy upper crusts. Europa in particular has even some degree of natural heating, with the pull of Jupiter's gravity producing natural temperature fluctuations. If life exists anywhere in our solar system, chances are good that it will be here. Enceladus and Titan, the moons of Saturn, are likewise good candidates. Enceladus spews water vapor from its surface, and the presence of hydrogen cyanide, a key building block of life, has also been identified. Titan, meanwhile, is also confirmed to house carbon-rich liquid, even if it's extremely cold and could only support living organisms that are not yet known to exist. And last on the list is Triton, a moon of Neptune that may also have an ocean below its icy surface. Triton is especially interesting because naturally occurring geysers erupt when nitrogen ice is heated by the sun, providing plenty of opportunity for living organisms to thrive. Following the current established rules for life, each of these moons holds promise, though it will likely be some time before any attempt is made at exploration. In the meantime, NASA and other space organizations remain focused on Mars, and more specifically, the intriguing leopard spot rock covered in our Fates of Mars rovers video. The leopard spots are good indicators of chemical reactions relating to life, though we'll have to wait until the rock gets back to Earth in 2033 for a closer look. Thank you for watching.